Artificial intelligence, it's everywhere right now, isn't it? Like the ultimate buzzword, you see it plastered on everything.
Oh, absolutely.
And as you navigate this landscape, maybe you felt that moment of, okay, but what is it really?
Yeah.
It turns out defining AI is surprisingly tricky. You know, the sci-fi writer Ted Chiang even called artificial intelligence a poor choice of words way back in 1954.
Hmm.
That feels pretty relevant today, especially when marketing hype can make it even, well, muddier.
It absolutely
Yeah.
is. Yeah, it sounds like it should have this single, straightforward definition. But as the article we're digging into highlights, it's much more fluid.
The source we're using today.
Right. We're digging into What is AI? A Human Guide to Artificial Intelligence by Harry Guinness today. And it does a fantastic job, I think, of trying to cut through some of that confusion.
And that's exactly our mission for this deep dive. We're going to unpack this article, pull out the core ideas, look at how AI actually works, where it came from, what it's doing right now, and maybe where it might be headed.
Sounds good.
The goal is really for you to walk away feeling genuinely informed, maybe a bit like overwhelmed by all the complexity, all based on what this source tells us.
Okay, so let's unpack that. What's the fundamental concept this article gives us for AI? At its heart, it's about a machine that can learn, make decisions, and, crucially, take action, even when it hits a situation it hasn't specifically been programmed for or seen before.
Right, and the article gives this great contrast with, like, a non-AI program. Remember that example of the simple paperclip robot?
Mm-hmm.
It's only programmed for one thing: bend wire into a paperclip. That's it. If you feed it dry spaghetti, it just snaps it. There's no ability to adapt or, figure things out on its own.
And this really highlights that crucial difference AI brings. These systems, they need to be able to handle the messiness of the real world, right?
Yeah.
All the variables you just can't predict.
Yeah.
The article uses the driverless car as a perfect example. You can't possibly program a car for every single street corner, every pedestrian doing something weird, every unique traffic light scenario.
No way.
You need a system that uses sensors to understand its environment in the moment and react correctly, even if it's never seen that exact combination of events before.
Yeah.
The core idea is really adaptation beyond just the explicit programming.
Which leads us straight to a key distinction the article makes, and this is really important to grasp right away. Artificial narrow intelligence, or ANI.
Sometimes called weak AI, yeah.
Exactly, weak AI. And this is what we have pretty much everywhere today. AI is built and trained for specific narrow tasks.
Right.
Think ChatGPT for generating text or a self-driving car just for navigating roads. They can be incredibly powerful within their domain,
Absolutely.
but they can't jump outside of it. You can't ask the car to write you a poem or expect ChatGPT to parallel park for you.
Exactly. And then there's the other side of the coin. Artificial general intelligence, AGI, or strong AI.
Sci-fi stuff.
That's the one. This is the human level, maybe even superhuman intelligence you see in movies. Something capable of learning, reasoning, and adapting across a vast range of tasks, applying knowledge broadly. But the article is quite clear on this.
Yeah.
This is still a long way off. It's the theoretical goal, the dream, not our current reality.
And maybe one important little nugget of caution right at the start from the article. When you see products marketed with AI splashed all over them, take a moment, maybe dig a little deeper. Is it truly a system that learns and adapts, or is it maybe just complex automation or a set of pre-programmed rules wrapped up in a buzzword? Worth asking.
Is a very good point, and it raises the next logical question. How do these ANI systems, the ones we do have, actually work? How do they learn?
Right.
The source explains that the engine behind most modern AI relies very heavily on something called machine learning.
Machine learning. Okay, so at its heart, if I understand the article correctly, it's about feeding just massive amounts of data into a computer.
Huge amounts.
And letting the computer learn from that data. It figures out patterns, makes predictions, decides on actions, rather than a human programmer having to write explicit instructions for every single tiny possibility.
Exactly. And the success really hinges on the quality and, crucially, the sheer quantity of the data you feed it.
The scale mentioned in the article is just, wow, it's kind of mind-boggling. Like models such as GPT-3 and GPT-4, the things behind ChatGPT,
Yeah.
trained on nearly 500 billion text tokens. That's just words and parts of words.
It's immense. And for image generation tools like Stable Diffusion, the dataset mentioned involved 5.85 billion text-image pairs. Gives you a sense of the scale you need to really teach these systems effectively.
And when we talk about machine learning, we often hear about neural networks and deep learning. The article describes these as complex, layered algorithms kind of inspired by the structure of the human brain.
Right, like interconnected nodes.
Yeah, and deep learning specifically refers to using networks with many, many layers, sometimes millions or even billions of parameters, these sort of tunable knobs within the network.
What's fascinating, though, about these really complex, deep neural networks, as the article points out, is they can lead to what people often call the black box problem.
Ah, right, I've heard that term.
Yeah, it becomes really difficult, sometimes even for the engineers who built them, to fully understand why the system made a particular decision or produced a specific output. You see the input, you see the output, but the intricate process happening in those hidden layers, it's often opaque.
And the article notes this opacity can actually contribute to problems, right? Like unintended biases showing up in the output because they were lurking in the training data, and you can't easily trace why.
Precisely. It's a significant challenge.
But machine learning isn't the only way systems learn, is it? The article mentions other approaches.
That's right. It gives examples like DeepMind's AlphaZero, which learned to play chess or Go, not from human games, but just by being given the rules and playing against itself millions and millions of times. It developed strategies humans hadn't even conceived of, purely through self-play, optimizing towards the goal of winning.
So, okay, we've covered the core idea, learning and adapting, and the main engine, machine learning, often using neural nets. The source also helps clarify some of the other related terms you hear thrown around all the time.
Yes, helps put the pieces together. For instance, generative AI, that's been huge recently.
Definitely.
The article explains this is AI that specifically creates new content, so text, images, music, code, based on the patterns and structures it learned from its massive training data. Think GPT creating text or DALL-E 2 making images.
Right, it's generating something new, but based on what it's already seen.
Exactly. Then there's natural language processing, or NLP.
NLP.
This is all about enabling AI to understand, interpret, and work with human language. It's not just matching keywords. It's about understanding context, sentiment, complex grammar, nuance. It's fundamental for chatbots, large language models, but also things like translation or analyzing customer feedback.
And computer vision. That seems pretty straightforward.
Yeah, basically letting AI see and interpret the world through images, videos, or data from sensors. Essential for self-driving cars to understand surroundings,
Right.
but also for medical image analysis, or even just your phone recognizing faces and photos, or reading text out loud for accessibility.
Okay. And the article also touches on automation, making a distinction between robotic process automation, RPA.
Which is more basic.
Yeah, following strict pre-programmed rules for repetitive tasks like data entry. And it contrasts that with intelligent automation, or IA.
Right. IA adds that element of learning and adaptation. It can actually improve processes over time without direct human intervention. The article uses the example of automatically A/B testing different marketing messages and optimizing based on results.
That helps clear things up. So maybe it helps to just quickly bring it back to those core distinctions again. Machine learning.
Is a technique.
Right, a technique within the broader field of AI. AI is the
Okay.
big goal, creating intelligent machines. ML is a primary method we're using today to get there, but not the only one.
Precisely. And that vital difference between the task-specific narrow AI we have now, which is powerful but limited,
Yeah.
and the broad, adaptable general AI we sometimes imagine.
The AGI. The article brings in Steve Wozniak's coffee test here, which I thought was a fun way to think about it.
It's quite intuitive, isn't it?
Yeah, could a robot go into a completely unfamiliar house, figure out where everything is, find the coffee machine, the beans, the water, a mug, and actually brew a decent cup of coffee, all completely uninstructed?
And when you frame it like that,
It really underscores just how far off that kind of flexible, general problem-solving capability still is. We are nowhere near that yet.
not even close.
So, if AGI is still firmly in the realm of sci-fi for now, where is the narrow AI, the AI we do have, actually being used right now? How does it connect to you, the listener?
Well, the article gives some really practical examples across different areas of work, showing it's not just theoretical.
Okay.
Absolutely. So in customer service, for instance, you're seeing AI handling initial inquiries, routing calls more efficiently, maybe providing instant answers to common questions via chatbots.
Saves waiting times sometimes.
Hopefully. For marketing teams, it's doing things like generating draft copy for ads or emails, designing variations of visuals, or helping optimize where advertising budget is spent based on performance.
Makes sense.
IT operations use AI quite a bit for monitoring complex systems, trying to predict potential hardware failures before they happen, or automating routine maintenance tasks.
And cybersecurity seems like a big one.
Huge. AI is crucial there for sifting through massive amounts of network traffic data to detect anomalies, identify patterns that might indicate a potential threat or an ongoing breach much faster than humans could.
And the article points out that it's not just about these, giant enterprise systems. There are loads of readily available AI tools out there now for individuals and small businesses too.
That's right. Tools for helping with writing, generating images, analyzing data, boosting productivity. The source even mentions specifically connecting these tools using platforms like Zapier to integrate AI capabilities into your existing personal or business workflows.
So you can hook them up to the apps you already use.
Exactly. These are all real-world examples showing how AI is already practical and useful today, often working quietly in the background, freeing up human time and energy for hopefully more complex or creative tasks.
Of course, it's not all smooth sailing, is it? As the article acknowledges, there are significant challenges and downsides that come with implementing and using AI. People have concerns.
Definitely. The source lists several key concerns you often hear. Things like the practical difficulties of integrating AI with existing legacy systems.
That sounds tricky.
The challenge of getting employees, or even customers, to actually adopt and trust new AI-powered tools. And that fundamental dependency on needing huge volumes of high-quality, often unbiased data to train these systems effectively in the first place. Finding that data can be hard.
And ethical issues too, right? Bias, misinformation, copyright questions around generative AI.
All major concerns mentioned. But on the flip side, the article also presents some pretty powerful benefits.
Okay, the good stuff.
Right. Beyond just saving time and energy by automating repetitive tasks, AI can significantly increase efficiency. It can potentially improve customer satisfaction by providing faster service or enabling completely new features.
And creativity.
Yeah, it suggests AI can act as a powerful tool to promote human creativity, maybe by taking on the drudgery or providing inspiration or handling parts of the creative process. And fundamentally, it's enabling entirely new capabilities that just weren't possible before. Think widespread personal assistance, or eventually things like fully autonomous systems.
It's important to remember, though, as the article stresses, that we didn't just arrive here overnight, this current AI boom.
It feels sudden, maybe.
Yeah, it feels sudden, but the article takes us through this brief but really illuminating history, framing this moment as something that's actually been building for decades.
That's a key point.
Yeah.
The seeds were planted a long time ago. You go back to the 1940s, you see the development of the first electronic computers, and alongside them, early theoretical ideas about neural networks, a lot of it spurred by the technological needs of World War II.
Then the 1950s and 60s seemed like a period of intense optimism. Alan Turing proposed his famous test in 1950.
The imitation game.
Right. The term artificial intelligence itself was coined in 1956 at that famous Dartmouth workshop. And you had prominent figures like Herbert Simon making really bold predictions back then, saying machines would be capable of doing any work a man can do within 20 years.
Which didn't quite pan out. That early optimism ran headfirst into the limitations of the technology at the time. The 1970s saw what's known as the first AI winter.
Right. Funding dried up.
Exactly. Progress slowed significantly because the computers just weren't powerful enough and the data wasn't available to handle the really complex problems AI researchers were trying to tackle.
There was a brief revival, though, in the early 1980s with something called expert systems.
That's right. These were commercial systems designed for very specific domains of knowledge, like medical diagnosis or financial planning. They had some success, but it led to another bubble.
Which burst. Yeah.
Leading to the second AI winter in the late 80s and early 90s. Many of those early AI companies failed because the technology, again, couldn't quite live up to the hype generated around it.
So what changed? The real turning point, according to the article, started in the late 90s and really accelerated into the 2000s and up to today. What was the key?
Crucially, computing power finally started catching up to the theoretical ideas. Moore's law, faster processors, more storage, and the explosion of digital data from the internet.
The datis again.
Exactly. You had milestones people noticed, like IBM's Deep Blue beating Garry Kasparov in chess in 1997, or IBM's Watson winning Jeopardy in 2011. Those showed increasing capability on specific complex tasks.
But maybe more significant, as the article points out, was AI quietly becoming embedded in everyday tools most people were already using without even thinking about it.
Yeah, improving your Google search results, filtering your email spam, recommending products on Amazon, targeting ads. It became practical and useful before most people consciously labeled it AI.
And the article specifically flags Google's development of the transformer architecture in 2017 as a really pivotal moment for modern AI.
Absolutely. That fundamentally changed how AI systems could process sequential data, especially language, and it really laid the groundwork for the large language models like GPT that are making headlines today.
So that brings us pretty much up to date. Looking ahead then, based on this trajectory, what does the source predict for the future?
Well, it suggests we're likely to see a continued shift in human roles in the workplace as AI takes over more routine automatable tasks.
Humans do.
What? Humans focus more on strategic thinking, creativity, complex problem solving, and interpersonal interaction, the things AI isn't good at yet.
Okay.
The article also suggests we'll probably see more AI systems interacting directly with other AI systems, potentially automating entire multi-step processes end-to-end without much human intervention in the loop.
And new jobs.
Naturally, new job roles will emerge specifically focused on building, managing, training, and working alongside AI systems. Prompt engineers, AI ethicists, data curators.
And a key prediction seems to be that AI won't just exist in these special dedicated AI tools.
Right. The prediction is it will become a standard feature, almost invisible, seamlessly integrated into all the software applications and devices we already rely on daily.
So the concluding thought from this section of the article seems pretty clear. AI is fundamentally changing the nature of work, and adapting to that change, learning to work with AI is becoming essential.
It really feels that way. So this deep dive into Harry Guinness's article, hopefully, has given us a pretty solid foundation. We've taken a closer look at what AI actually means beyond the buzzword, how modern AI is largely powered by machine learning and these huge neural networks, clarified some of that key terminology, like ANI versus AGI, ML versus AI,
Yeah, getting those straight helps.
explored its practical uses right now, balanced the very real benefits against the significant challenges and concerns, and traced that long history that brought us to this particular moment.
It's clear that AI is complex, it's definitely constantly evolving fast, and it's already much more integrated into our lives than many of us might realize, often operating just behind the scenes.
And understanding these core concepts, these fundamentals drawn from the source, hopefully empowers you, the listener, to look beyond the hype cycles, to evaluate claims about AI more critically, and to think more clearly about its actual role and its potential role in the world around you.
And that final idea from the article about adapting to the changing nature of work because of AI, that feels like a really crucial takeaway to end on. It's not just about learning to use a new tool like mastering Excel, is it?
No, it seems much bigger than that.
Feels like it prompts a deeper reflection on, rethinking entire workflows, maybe even reconsidering certain skill sets or career paths as these AI capabilities become more and more widespread and integrated.
And as AI gets woven more deeply into everything, that technical challenge we talked about, the black box problem, not always fully understanding why a system makes a certain decision,
Yeah.
that becomes something we all need to consider more seriously, doesn't it? In terms of trust, reliability, fairness, especially as we rely on these systems for more important things, it definitely gives you something to chew on as you encounter AI, out there in your daily life.